Welcome to the new session of the subject Transportation Engineering 1. So in the previous session, we have gone through the concepts of side distance, what are the types of side distance, what are the factors affecting the side distance, and also we have seen the theory of PIEV, that is nothing but perception, intellection, emotion, and volition. So today in the session, we are going to see the problems based on stopping side distance, which are asked in the exam. Okay, so basically SSD is nothing but the stopping side distance in meters we are going to calculate. The formula for that is nothing but 0.278 V into T plus V square divided by 254, okay, into F, where this V is nothing but the speed of the vehicle in terms of kilometers per hour. Small t is nothing but the reaction time in seconds, which is 2.5 seconds standard given by the IRC. Small f is nothing but the coefficient of friction between the tires and the pavement, so which is ranging from 0.40 to 0.35 for the speeds ranging from 20 to 100 km/h. So we'll see the numericals. Before that, there are certain corrections to be applied whenever vehicle is going to travel on a particular slope or on the gradient. So there is just a change that the same formula will be used only in that the nature of the slope, whether it is upwards or downwards, that is the moment of the vehicle, it will just be added with respect to the friction. So the formula will be SSD in meters is equal to 0.278 into V into T plus V square divided by 254 into bracket F plus minus small n divided by 100, where n is nothing but the gradient or slope in percentage. N vertical to 100 horizontal. So n is positive when the vehicles are moving upwards and negative when the vehicles are moving down the way. This is the equation number 2. So previous it was the equation number 1 and this is the equation number 2. Okay, so we'll see the examples on stopping side distance. So numerical 1 question: calculate the stopping side distance for design speed of 60 km/h. So assume f is equal to 0.36. So what they are asking to calculate the stopping side distance for the vehicle which is traveling at a speed of design speed of 60 km/h, for which the coefficient of friction F is given as 0.36. So we'll solve it. So the formula for this, it is, as we have seen, it is 0.278 into V into T plus V square upon 254 into F. So here you can see they have not mentioned that whether the vehicle which is traveling at the design speed of 60 km/h, whether it is traveling on a plain road or on a slope road. So we'll be using the equation number 1, which is not having any kind of corresponding nature or gradient or slope. So they are given the value of V, that is velocity or the speed at which the corresponding vehicle is going to travel, and T is the standard time, that is 2.5. So just we'll substitute here. So 0.278 into 60, that is the design speed, and 2.5 seconds, that is the time, standard time as per the IRC. We'll substitute the value of V 60 square divided by 254 into 0.36, which is given here. So the value comes out to be 81.07 meters after calculating this. So remember, the unit is important, that is stopping side distance is 81.07 meters. So conclusion should be the safe stopping side distance is 81.07 meters. Okay, so what was the question? To calculate the stopping side distance for design speed of 60 km/h while assuming f is equal to 0.36. So after just substituting the values, we have calculated it. Thus, the safe stopping side distance is coming out to be 18.07 meter. So we'll go more further to the next level of the numerical. Next, calculate the minimum side distance required to avoid head-on collision of car having speed of 60 km/h for single lane traffic. Assume total reaction as 2.5 seconds, frictional coefficient 0.7 and brake efficiency 70%. Okay, so for that solution, so again now here they are not mentioned any kind of slope, that is the value of n. So we'll make use of the equation number 1. So SSD in meters, the formula is given as 0.278 into V into T plus V squared divided by 254 into F. So just substitute those values. So the design speed is 60 kmph, standard time they are given as 2.5 reaction time. And now what they are given, the brake efficiency is 70%. So just make sure that in the previous numerical, the brake efficiency was not given, so which is directly rated with the friction of the road and the tire. So they are telling that the brake efficiency is 70. So the frictional resistance will be multiplied by this 70%, that is 0.7. And we'll calculate the stopping side distance, minimum side distance required. Okay, so it is coming out to be 70.62 meter. But in the conclusion, it is written here I have 141.25 meter. So just remember clearly why I written, because for single lane, okay, the correspondingly traffic is moving in the both direction. Okay, so you are required to just double it, the distance which is been calculated. So calculated distance is coming out to be 70.62 meter. So it is just doubled. Okay, moving to the next problem. Calculate the stopping side distance for a two-lane road with a design speed of 70 kmph. The road is at down gradient of 3%. Assume total reaction is 2.5 seconds, frictional coefficient as 0.35 seconds. So now the numerical has more complexity, okay, or the corresponding level of numerical has been increased. So in the initial case, we have just solved what was the stopping side distance. Then we have increased level, difficulty level. That is, in that we have mentioned what was the brake efficiency and also whether it was a single lane road or the correspondingly it was traveling on a single lane road. So we have doubled the answer. And now here you can see the level of difficulty has been again increased, in which it has been mentioned that the slope or the down gradient is 3%. So now we will be making here use of the formula, that is of the equation number 2. Okay, so in which the plus or minus sign of the slope is been added. Okay, so just substitute those values in this equation. So 0.278 into 70 into 2.5. So 70 is nothing but the design speed which is given. Then correspondingly reaction time they are also given as 2.5. Just substitute here. And now as they are told that the road is having a down gradient of 3%, so we'll be making of the sign minus. So it is representing the minus. So 3% divided by 100. So now just calculate it. So it is coming out to be 108.935 meters. Okay, so the conclusion should be safe stopping side distance for a vehicle which is traveling at a speed of 70 kmph on a two-lane road with a road having a down gradient of 3%, total reaction time of 2.5 seconds, and frictional coefficient 0.35 seconds is nothing but 108.935 meters. Okay, so these were the numericals which are been asked in the paper or which might be asked in the paper, okay, in the examination. Okay, so in the next session we will see overtaking side distance and the numericals based on it. Thank you.